All right, UPSC aspirants getting ready for those mains and prelims. We've got a story today that's, well, it's made global news, and it's got some angles you want to be aware of.
Absolutely. It's one of those things that might seem simple at first glance, but the more you dig in, the more connections you find to all sorts of topics.
Exactly. So we're talking about A23a, the world's biggest iceberg. I mean, that alone is kind of impressive, right?
Hmm.
This thing was adrift for decades, and now it's run aground off South Georgia Island.
And that grounding, that's where things get really interesting, especially for those exams you mentioned. Because it's not just a geography fact, it ties into ecology, ocean currents, even hints at the bigger climate change picture. Luckily, we've got some insights from the British Antarctic Survey to help us unpack it all.
So let's dive in, shall we? First off, this journey of A23a, it's pretty wild. Broke off from Antarctica back in '86, just kind of hung out there for over 30 years, and then boom, 2020 rolls around and it decides to go on a trip.
Yeah, it's almost like it was, I don't know, taking a nap or something, and then suddenly woke up and said, all right, time to move. And now it's grounded again, about 90 kilometers off South Georgia. The Mapping and Geographic Information Center, they've got some great graphics tracking this whole thing, really shows you the scale of it. But yeah, that unpredictable behavior, that's what makes it such a puzzle for scientists.
A puzzle for sure. But I'm kind of asked, it's a huge iceberg, sure, but is this grounding really that big a deal? I mean, it's just sort of stuck now, right?
Well, think about it this way. When an iceberg is just floating around, it's largely at the mercy of those ocean currents. But once it gets grounded, like A23A has now, it becomes a much more permanent part of that local environment. And that means a much more focused, potentially big impact on the ecosystem around it, even things like commercial fishing. It's not just drifting through anymore.
Oh, I see. So it's all about location, 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 huh? And South Georgia, that's not just any random spot in the ocean. It's a pretty important place for wildlife, isn't it? Lots of penguins, seals, that sort of thing.
Right, exactly. Dr. Andrew Migers, he's an oceanographer with the British Antarctic Survey. He's actually voiced some concerns about A23A potentially disrupting those commercial fisheries in the area. But it's the ecological impacts that are really, well, they're fascinating, to say the least. Lots of potential knock-on effects we're only beginning to understand.
Yeah, in the research I was doing, I saw that, yeah, potential harm to seals and penguins, their feeding grounds could get messed up. But then there's also this idea that the iceberg melting could actually be good for the food chain, releases nutrients as it melts. It's like A23A is this giant icy paradox.
And that's what makes it such a cool case study, right? It's not just a simple, this causes that situation. On the one hand, yeah, you've got potential disruption, things getting thrown out of whack. But then you've also got this possibility of a boost to the food chain lower down, those nutrients feeding the tiniest creatures, and that impact ripples upwards. The British Antarctic Survey, they're actually doing a bunch of research right now on these mega icebergs like A23A, trying to untangle those complex relationships. It's not easy stuff.
Yeah, I can imagine. So we've got this giant iceberg acting like, I don't know, a shakeup for the whole environment. But before we get too far ahead of ourselves, I'm curious, how did A23A even get stuck in the first place? I mean, it calved back in '86, but then just sat there for ages. What was going on?
Uh, that's where the geography gets really cool. So the thinking is that A23A got trapped in something called a Taylor column. Basically, picture this column of rotating water. It sits above a seamount on the ocean floor, almost like I guess you could say like a giant whirlpool, but way slower moving. And that rotating water, it can trap these huge icebergs, basically pinning them in place sometimes for years, even decades.
So it's like I don't know, a frozen whirlpool. That's wild. And now it's free, off on its adventure, and scientists are scrambling to figure out what it all means. Speaking of which, I read that the British Antarctic Survey, they actually sent a team out to A23A back in December. Went right up to it, did some hands-on research.
Yeah, that's right. They went aboard the RRS, or David Attenborough. That's one of the most, well, it's a cutting-edge polar research vessel.
Yeah.
And what they were doing out there, it's actually key to understanding this whole impact thing. They were taking samples, trying to analyze the water, the biogeochemistry of it all.
Biogeo what now? Sorry, I know we're supposed to be the UPSC experts here, but could you break that down a little? What were they actually looking at?
Oh, sure, no problem. Biogeochemistry, it's basically the study of how, how the chemistry, the physics, and the biology of an environment all work together. It's all interconnected. So in this case, the team, they were looking at things like nutrient concentrations, phytoplankton levels, that kind of stuff, comparing what they found to, what you'd normally expect to see in those waters, trying to see if A23A is throwing things off balance.
Ah, so they're trying to figure out how this giant iceberg is messing with the chemistry set of the ocean. and how that might impact those tiny organisms, the phytoplankton, which of course are the base of the whole food web. It's like a giant domino effect.
Exactly. And it's not just about this one iceberg, you know. This research, it helps us understand how icebergs in general, all over the place, influence the oceans. Things like how nutrients get cycled, even how much carbon the ocean can absorb.
Carbon, like carbon dioxide, the stuff that's driving climate change. Hold on, are we saying that this iceberg, A23a, could actually be playing a role in that whole global warming thing?
You're catching on quickly. And yeah, that brings us to the big question everyone's thinking about. Is this whole saga, is it climate change in action? I mean, it's hard not to connect the dots, right? All the news about melting glaciers, rising sea levels, it's all tied together.
It really is. So what's the answer? Is A23a a climate change refugee? Or is that oversimplifying things?
Well, Dr. Meijers, he explains it pretty well. Icebergs themselves, they're a natural part of the Antarctic, always have been. They've been breaking off from ice shelves for, well, probably forever. What's linked to climate change, though, is the rate at which it's happening, the speed at which these things are calving.
Oh, okay, so it's like climate change is hitting the fast forward button on the whole process. But how does that actually work? What's the mechanism there?
Think of it this way. As the planet warms up, those Antarctic ice shelves, they get thinner, more fragile. It's like, imagine weakening the foundation of a house. Makes them much more likely to crack, to break apart, and that leads to more icebergs, bigger ones, breaking off more often.
Okay, I'm getting the picture. Warmer temperatures, weaker ice, more icebergs breaking free.
Yeah.
And that, well, that has consequences that go way beyond just some penguins having to find a new fishing spot, right? This is global stuff we're talking about.
Exactly. That extra fresh water from the melting icebergs, it can disrupt ocean currents, which are like the planet's circulation system. Mess with those and you mess with the climate big time. And of course, there's the sea level rise, threatening coastal communities all over.
Wow. Okay, so we've gone from one iceberg to potentially impacting the entire planet. This deep dive is getting pretty intense. We've covered A23a's journey, the impact on South Georgia, and how it all links back to this global climate crisis.
Yeah.
But we're just getting started. There's still so much more to unpack.
There is indeed. And in the next part of our deep dive, we're going to dig even deeper into the scientific side of things.
Yeah.
What makes A23a so valuable to researchers, what they're learning from it. And trust me, this is all crucial information for any UPSC aspirant out there. This is the kind of stuff that could pop up on those exams.
Absolutely. So make sure to join us for part 2, where we'll uncover even more about this fascinating iceberg and what it means for the world. And for those of you prepping for the UPSC, hit that subscribe button and leave us a comment with any questions you have. We're here to help you make sense of it all. And of course, a big shout out to the British Antarctic Survey. They're doing some amazing work down there in the Antarctic, and their research is what made this whole deep dive possible.
Welcome back, everyone. We're picking up our deep dive right where we left off with A23a, that massive iceberg parked off South Georgia.
Parked is right.
Yeah.
And it's not just physically grounded, right? It's like scientifically grounded, too. All the stuff I was reading, they kept calling it a natural laboratory. Gotta be exciting for the researchers, huh? A giant iceberg just waiting to be studied?
Oh, absolutely. It's a unique opportunity, really. With A23a, scientists can study so many things, you know, from the immediate impacts, how a huge chunk of ice affects the ecosystem right around it, to these bigger questions about ocean currents, climate change, the whole 9 yards. It's a chance to see these processes play out in real time.
So it's like nature's running this giant experiment, and scientists have front row seats. What are some of the key things they're hoping to learn from A23a? What makes it so valuable?
Well, one of the big ones is nutrient distribution. When an iceberg melts, it releases all sorts of stuff. Minerals, organic matter, you name it. And that acts like fertilizer for marine life. You know, imagine this, a sudden influx of nutrients into an ecosystem that's used to a certain balance. It's bound to have a ripple effect, potentially impacting everything from the tiny phytoplankton to the big guys, even whales.
So it's like a sudden energy boost for the whole ocean ecosystem. But wouldn't that have some negative consequences too? Like too much of a good thing, maybe?
You're on the right track. That's exactly what scientists are trying to figure out. Will it lead to this huge burst of productivity, or will it mess things up, disrupt the existing food webs? A23a is giving them this real-world case study, a chance to see how it all plays out.
And this brings us back to that climate change connection. We've talked about how warmer temperatures are leading to more icebergs breaking off. So if these giant ones, these mega icebergs, if they become more common, wouldn't that mean these nutrient pulses in the ocean would happen more often, like constantly shaking things up?
That's the big unknown, really. How will these shifts in nutrient dynamics affect the oceans in the long run? Will it lead to more productive ecosystems, or will it throw everything out of whack? These are the questions researchers are grappling with, and A23A is providing some valuable data points.
It's like we're getting this glimpse into a possible future for our oceans, a future shaped by climate change in ways we're only beginning to grasp.
Okay, so A23A is this incredible scientific opportunity, but I'm curious, how are they actually studying it? What kind of tools and techniques are they using? I mean, it's a giant iceberg in the middle of the ocean.
Well, for starters, they're using satellites, tracking A23A's movements, watching how it changes shape, even measuring how fast it's melting. All from space. Satellites can even pick up things like sea surface temperature, chlorophyll concentration, giving us clues about how the iceberg is affecting the surrounding environment.
So it's like having eyes in the sky watching the whole experiment unfold. But they're not just relying on satellites, are they? They're actually getting up close and personal with the iceberg, right? Sending people out there. You got it. In addition to the satellite data, scientists are using on-site research methods. They've got these underwater robots called gliders. They send them out to collect data on ocean currents, temperature, salinity, all that stuff, right around the iceberg. And they're taking water samples, analyzing them for their chemical makeup, seeing what kind of organisms are present. Real hands-on stuff.
It's like a full-blown investigation, high-tech tools, researchers braving the icy waters. I mean, those nature documentaries.
And this is exactly the kind of real-world science that connects to current events, policy decisions, all that. Remember, UPSC aspirants, this isn't just a science story. It's a story about interconnectedness, how something that happens way down in Antarctica, an iceberg breaking off, can have repercussions for the whole planet. It's all connected.
It really makes you think, doesn't it? What happens in one corner of the world can affect us all. Now, while researchers are busy studying A23A, there's also the question of what happens next. I mean, it can't stay grounded forever, can it?
That's the million-dollar question, isn't it? What's the fate of this giant iceberg?
Will it keep moving, break apart, melt away? What does that mean for South Georgia, for the region? It's like a cliffhanger ending to our deep dive.
A cliffhanger indeed. To answer those questions, we need to look at where A23A is right now, the ocean currents, and, of course, the unpredictable nature of icebergs themselves. It's a fascinating story, and it's not over yet.
Welcome back to the deep dive, everyone, especially our UPSC folks. We've been on this incredible journey with A23A, this mega iceberg, from breaking off in Antarctica to its current spot near South Georgia. It's been a wild ride. So here we are, the final part of our deep dive. The big question on everyone's mind is, what's next for this icy giant? What's going to happen to it?
That's the million-dollar question, all right? And even with all the science and technology we have, it's tough to say for sure. Icebergs, especially one as massive as this one, they kind of have a mind of their own.
Yeah, so even with all our fancy models and predictions, we're still at the mercy of Mother Nature, huh? Kind of humbling, but also a bit unnerving when you think about it.
It is. It is. We can track its movements, study its composition, even predict its path to some extent. But ultimately, its fate, it all comes down to this complex mix of things, ocean currents, wind patterns, the Southern Ocean just doing its thing. It's a dynamic system.
So predicting A23A's future is a bit like, I don't know, trying to predict the weather, right? You got your patterns, your indicators, but there's always that element of surprise. But I'm guessing scientists have some ideas, some educated guesses about what might happen, don't they?
Oh, they definitely have some thoughts. Based on its current position, its size, the ocean currents in that area, well, the most likely scenario is that A23A will eventually break apart. It's a natural process, especially as icebergs drift into warmer waters. They get battered by wind and waves. It's like erosion on a massive scale.
So instead of this one giant iceberg, we might end up with a bunch of smaller ones, still pretty big chunks of ice, but scattered around. What does that mean? What are the implications of that?
From a scientific standpoint, well, it's another exciting research opportunity. Scientists want to understand how these smaller icebergs, they call them bergy bits or growlers sometimes, how they behave, how they spread out, how they melt, all that stuff.
It's like A23A is giving us one last science project before it disappears completely. But I remember from the research that there were some concerns about these smaller icebergs being dangerous, especially for ships, like harder to track, harder to avoid.
Yeah, that's a real concern. A huge iceberg like A23A, well, it's pretty easy to spot, to stay clear of. But when it breaks up, those smaller pieces, they're much harder to detect, especially in rough seas or if visibility is bad.
So it's like going from avoiding a mountain to dodging a bunch of rocks in the road. That sounds pretty dangerous for ships in those waters.
Exactly. The risk of collisions goes way up, and that can be bad news, potentially disastrous, especially for smaller vessels.
Yeah.
And this is a key point, for UPSC aspirants especially. These environmental events like icebergs, calving, melting, they're not just scientific curiosities. They have real-world impacts on industries, economies, global safety even.
This deep dive has really opened my eyes. We've covered the science, the environmental effects, even the potential economic and safety issues, and all from this one iceberg. It really shows how interconnected everything is, how something happening way down in Antarctica can ripple out and affect us all.
It does, it does. It's a reminder that we're all connected, that what happens in one corner of the world matters everywhere.
Absolutely. Well, folks, we've reached the end of our deep dive into the world of A23a. We've covered its journey, its impacts on the Southern Ocean, its role as this incredible natural laboratory, and what might happen as it eventually fades away. It's been a fascinating exploration, and I hope it's given you all, especially those preparing for the UPSC exams, a lot to think about.
Remember, staying informed about current events, understanding the science behind it all, that's key for those exams, and for being an engaged citizen of the world.
Couldn't have said it better myself. So keep exploring, keep asking questions, and keep diving deep into the world around you. And before we sign off, don't forget to hit that like button, subscribe to the channel, and leave us a comment if you have any questions. We're here to help you make sense of it all. And a huge thank you to the British Antarctic Survey. Their amazing work in the Antarctic made this whole deep dive possible.